Same as thermochemistry. Same as thermochemistry, you have calculation, chemistry calculation part in kinetic chemistry. Let's move into paper. Okay, it's very simple paper. You have only three, as I remember, you have only three advanced MCQ questions, and other all questions are very simple. Which of the following is not a physical change? Which of following are not a physical change? Yeah, sublimation is a physical state change. What's the meaning of sublimation? Solid directly convert into vapor without convert to liquid. Directly convert into vapor. Melting, solids convert into liquid at melting point. Solid convert into liquid at melting point. Reverse sublimation or deposition. The opposite side of the sublimation, vapor directly convert to solid. Vapor directly convert into solid. That one also physical state change. The condensation mean opposite of vaporization. Vapor convert into liquid, or gas convert into liquid. Formation of water from hydrogen, oxygen and hydrogen. It's a hydrogen and oxygen. It's a chemical reaction. It's not a physical change. Reactant and product, that means raw materials and final product is different. Their characteristic difference. Therefore, it's a chemical reaction. It's a chemical reaction. Chemical reaction. Answer number 4. It's a chemical reaction. Therefore, answer number 4. First one easy. The sublimation is that you already know. The sublimation means a solid change into liquid. What's the name of that? Solid change into liquid. It is melting. Melting. Liquid change into vapor. It is vaporization. At boiling point, vaporization. Solid change directly into vapor. Yeah, this is a sublimation. This is a sublimation. A liquid change into solid. What's the name of that? Liquid change into solid. Liquid change into solid. What's the name? Mariam. Liquid change into solid. Liquid change into solid. Yeah, freezing. Freezing. Good. Freezing. Freezing. A vapor change into liquid. It is condensation. 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 Okay, answer number 3. The melting refers to very simple things. What's the meaning of melting? What's the meaning of melting? Solid change into liquid. Solid change into vapor, it is sublimation. Liquid change into solid, It is freezing. Liquid change into vapor. It is vaporization. A vapor change into liquid. Condensation. Answer number 1. Solid change into liquid. Good. Answer number 1. Answer number 1. Which of the following is an endothermic process? Okay, dissolve sodium hydroxide in water. Sodium hydroxide is a base. Water and base reactions are exothermic. They are exothermic. Adding water to concentrated HCl. HCl is a powerful acid. Powerful acid react with water. That one also exothermic. Exothermic. Adding water to vinegar. Adding water to vinegar. What do you think? Water into vinegar. Yeah, that one also. Vinegar also acid. Yeah, vinegar acid. Then acid water reaction. That one also exothermic. This may HCl water reactions highly exothermic. That means it's produce huge amount of heat. Highly exothermic. But vinegar water, they are not weak acid. Vinegar mean acetic acid, they are weak acid. They produce very less amount of heat, not much heat, right? Adding water to quick limes. Limes mean calcium carbonate. They are base. Base and water reactions, that one also less exothermic reaction. It produces less amount of heat, exothermic. But dissolving urea in water, it's clear endothermic reaction. It's clear endothermic reaction. It's clear endothermic reaction. Endothermic process, answer number 5. Answer number 5. Give me a second. Okay, dissolving urea. I told in our syllabus how many endothermic reactions given? Urea water reaction, glucose and water reaction. What else? Ammonium minerals. Ammonium minerals mean ammonium hydroxide, ammonium chloride. This type of ammonium included, ammonium consists minerals react with water. They are also endothermic. They are also endothermic. The photosynthesis reaction is endothermic. The photosynthesis and okay, they are the main. And a lot of exothermic reactions, acid base reactions, acid water reactions, base water reactions. Yeah, the burning reactions. Not only that, acid and metal reactions, they all are exothermic. They all are exothermic. The characteristic of an isolated system. You know, According to the energy and matter exchange, systems mainly three types. What are the types? Open systems, closed systems, and isolated systems. Yeah, the question asks based on characteristic of isolated system. Isolated system. Exchange both energy and matter with surrounding. What is the system? It is open system. Open system is a system exchange both energy and matter. It's open, right? Open. Exchange energy only with surrounding, only energy exchange, it is closed system. Closed system, both wrong. The question asks a characteristic of isolated system. Exchange of matter only with surrounding, which type of system? Exchange matter only with surrounding? No, this type system, no? මෙහෙම system එකක් නැහැ. Closed system only energy exchange, open system energy and matter both exchange, right? No, this type of sealing of whole systems. Sealing systems, that means sealed systems are closed systems, not open system, isolated system. No exchange both energy and matter with surrounding. Answer number 5. Answer number 5. Which of the following is the closest example of an isolated system? Isolated system. Yeah, if you got battery cell, which type of system? Battery cell එකක් ගත්තහම which type of system? Battery cell mean normal battery. Which type of system? Open, closed, or isolated? Yeah, it is closed system. The battery is full sealed and energy exchange, it is heated, no? Heating mean it's only energy exchange, it is closed system. Closed system. A fish tank. Fish tank, which type of system? What's the type of system? It is open system. It is open system. A pressure cooker. Pressure cooker. Pressure cooker. Pressure cooker. Yeah, pressure cooker. Yeah, we can say if it is fully sealed, closed system. Closed system. A natural water body. Natural water body mean what? Pond එකක්. It's an open system. Then the closest example for isolated system, hot water bottle, but that one also not full isolated. Why? I told it's heat energy transfer, very slowly heat energy transfer. That's why the water cooling, no? එකයි වතුර cool වෙන්නේ. නිමෙන්. Right. Right, but that's a more suitable example, closest example. Yeah. What is the amount of heat absorbed in kilojoules? Yeah, these are most important questions starting from question number 7. What is the amount of heat absorbed in kilojoule when 200 grams of ice at -10 turns into 0 Celsius water? The specific heat capacity of ice is given and the specific latent heat of ice at melting is given. Right? Okay, now okay, what happened? Initially, it is -10 Celsius ice. -10 Celsius ice. -10 Celsius ice to convert into 0 Celsius water. First, it's reached to the melting point. To ice convert into water, the first melt trend on, got to melting, right? then it is reached to 0 Celsius ice. 0 Celsius ice. You know 0 Celsius is a melting point of melting temperature of ice. Then 0 Celsius ice convert to 0 Celsius water, that we called as a physical state change, that we called as melting. Physical state change. Ice convert into water. Solid water convert into liquid water without any temperature change. That's a physical state change. Physical state change without temperature change. Now you can get the Q equal. For this, there is a temperature change, no physical state change. Minus 10 to 0 Celsius ice, still ice, therefore MC theta, no physical state change, right? 0 Celsius ice now without temperature change the physical state. Change the physical state. Then it is ML. 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 Now, the mass of 200 grams, 200 grams, the specific heat capacity also given per grams. Per grams. Do you need to convert into kilograms? No. The specific heat capacity also given per grams. Then 4.2 joules per gram per Celsius. Right? Then temperature difference minus 10 to 0 Celsius. What is the difference? 10 Celsius. 10 Celsius. 10 Celsius. Plus again mass. What's the mass? 200 grams. 200 grams. 200 grams. You have to be very careful about units. And the specific latent heat of ice at melting is 334 joules per grams. 334 joules per grams. Then you don't need to convert into kilograms. 334 joules per grams. Now what happened? Now grams per grams cancel out. Celsius to per Celsius cancel out. Grams per grams cancel out. Okay, now you can get finally 200 into 4.2. Now 4.2 into 10 it is 42. 42 into 2 it is 84. 8,400. 200 into 334. 334 mean 668. Two zeros. Now you can add these two values. Now you can add these two values. Okay, 0. Okay, what's the value? Add karam kiye then. Yeah, 75,200 joules is the answer. Still joules. Still joules. They are the points. You have to be very careful. Unit conversions and answers given in different units. Hurry. Now, 75,200. 75,200. The question asks what is the amount of heat absorbed in kilojoules? They are the points. You have to very carefully read questions. In kilojoules. Joules 75,200. Then divide by 1000. 75.2 kilojoule is the heat amount in kilojoule. Answer number 2. Clear? Note down if you want. Okay, question number 8. If the heat of reaction between sodium hydroxide and HCl is minus 57 kilojoules per mole, the heat of reaction given. The heat of reaction given. What is the amount of heat released in kilojoules when 8 gram of sodium hydroxide react with 100 cubic centimeter of 2 mol Dm minus 3, 2 moles per cubic decimeter HCl solution? The relative atomic masses are given: hydrogen 1, oxygen 16 and sodium 23. Okay. The heat of reaction given minus 57 kilojoules per mole. Why it is minus? The heat of reaction minus. Then this reaction exothermic or endothermic? This reaction exothermic or endothermic? Yeah, definitely it is exothermic. That's why I told always if it is this reaction exothermic, reactant convert into product, some part of heat energy released to the environment, right? Some part of heat energy released to the environment. May release right? Due to that, always delta E mean energy change value minus value for exothermic reaction. Minus value for exothermic reaction. Example, think it is 10 joules, 5 joules release, only 5 remain for products. Then final energy minus initial energy is delta E, energy difference, energy change. 5 minus 10, it is minus 5. Minus 5. Always minus value. Therefore, exothermic reaction, the heat of reaction for exothermic reaction also minus. Minus 57 kilojoules per mole. What is the amount of heat released in kilojoule? That one also asking in kilojoule. That's the point. Kilojoules. When 8 gram of sodium hydroxide react with HCl solution. First, you have to get the equation. HCl, you know, this is a very basic equation. HCl plus sodium hydroxide, it is balance equation. Sodium chloride, NaCl plus water. It's already balanced. First, you can find the sodium hydroxide number of moles. Sodium hydroxide number of moles. Sodium hydroxide number of moles. What's the method? What's the method? First, you can get the atom molar mass. Sodium hydroxide molar mass. Sodium 23, oxygen 16, hydrogen 1. Then 23 plus 16 plus 1. It is 23 plus 17, 40. No, 40. Not 48. $48 or 40? 44. 40. You know, number of moles equal mass over molar mass. Mass over molar mass. Mass over molar mass, 8 over 8 grams divided by molar mass, 40 grams per mole. Grams per mole. Grams per 1 mole. Right? Then you can get grams to grams cancel out. 8 over 40 means 0.2. No? 1 over 5. 1 over 5 means 0.2. 0.2 moles sodium hydroxide number of moles. Now you can find HCl number of moles. HCl number of moles. The concentration is given. The concentration equal 2 moles per cubic decimeter and the volume is given. The concentration equal number of moles divided by volume. The concentration 2 equal number of moles, the volume given in cubic centimeters, 100 divided by 1000 to convert into cubic decimeter. To convert into cubic decimeter, 100 divided by 1000. Okay, then what is the number of moles? 2020 cancel, then 0.1 into 2, 0.2 moles, same number of moles. Then if it is HCl and sodium hydroxide, the equation balance, the stoichiometric ratio also sodium 1 to 1, sodium hydroxide to HCl 1 to 1. Then the number of moles also same. Number of moles same. Then which reactant will be remain, and which one is limited? Or all reactant? මොන හරි ඉතුරු වෙනවද? Anything remain? No, all reactants will be converted into product. All reactants will be converted into product, right? Then how to get the heat rate of reaction? Rate of reaction equal number of moles, sorry, quantity of heat divide Q divided by N. Q divided by N. The rate of reaction 57 minus 57 equal කොහෙද හදන්නේ අපි? Okay, the rate of reaction minus 57 kilojoules per mole. Kilojoules per mole. Kilojoules per mole equal quantity of heat Q divided by number of moles. The reacted number of moles, all reactants will be reacted, then 0.2 mole, right? Now you can get the cross multiplication. 57 into 0.2. 57 into 0. Per mole to mole cancel out. Then the answer remain with kilojoule. Answer coming with kilojoule. Kilojoules වලින් තමයි. Then 57 into 0.2. What's the answer? Minus 11.4. Minus 11.4. Sorry, answer number 4. Clear, Mariam? Okay. 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 Note down. Okay, the temperature of 1 kilogram of calcium carbonate is 30 Celsius and its decomposition temperature 900 Celsius. What is the amount of heat required in kilojoules to bring this amount of calcium carbonate to the decomposition temperature? The amount of heat required to increase the temperature of calcium carbonate up to 900 Celsius. 900 Celsius. Then initial temperature 30 Celsius. The specific heat capacity given, but it is given in per grams. They are the points you have to be more careful. Okay, then the quantity of heat, the specific heat capacity given, and no physical state change. No physical state change up to 900 Celsius. Then MC theta, no physical state change. The mass of calcium carbonate 1 kilogram, but you have to substitute in grams now. 1 kilogram in 1000 grams because specific heat capacity given in per grams. If not, if you got 1 kilogram, you have to convert specific heat capacity into per kilogram, right? This is a best way. 1000 into 0.9 joules per grams per Celsius into temperature difference 30 Celsius to 900 Celsius 870 Celsius. Now you can cancel out grams to per grams, say per Celsius to Celsius. Right? Now the final answer joules. Joules වලින් තමයි එන්නේ. Then 1000 into 0.9. It's 0.9. 1000 into 0.9, 900. 900 into 870. 900 into 870. What's the answer? 900 into 870. Yeah, 783,000 joules. 783,000. But the question asks in kilojoules. They are the points you have to be very careful. In kilojoules, it is 783 kilojoules divided by 1000. 783 kilojoules, the answer number 2. 783 kilojoules, answer number 2. Okay, if you want, clearly note down. now okay, right? Okay, I told you. Make a hunade. First one, okay, right? Ah, in any chemical reaction, reactant molecule collide each other. That's true. That's the main requirement to take place any chemical reaction. Reactant molecule collide each other. It's already available bonds breakdown and new bonds formation. These new, after new bond formation, the new products are the products of this any chemical reaction, right? Products of any chemical reactions. Okay, that we discussed in our kinetic chemistry next lesson in details what's the mechanism of take place a chemical reaction, right? Collisions of molecule occurring during mixing of raw materials. Yeah, collision is true. Collision is true, but if it is exothermic reaction, it's produce heat during collision. If it is endothermic reaction, it's loss heat mean cool down. Therefore, not always increase in temperature due to collision. If it is exothermic reaction, it's produce heat. Endothermic reaction, it's cool down, cool down, loss heat, loss heat. Actually, cool down, right? Cool down, decrease the temperature. The reaction being exothermic, yeah, that's the exact reason. That's the exact reason. The reaction being endothermic, if it is endothermic, it's cool down, cool down. Due to use of catalyst is not, catalyst mean increase the rate of chemical reaction or control the rate of chemical reaction, changing activation energy that we can discuss in next lesson, kinetic chemistry. The system being an open system, the open clause is not related to this question, right? The reaction is asking the reaction being exothermic. Answer number 2, very simple. A motor vehicle driven by a liquid hydrocarbon fuel required 10 kilogram of fuel to travel 100 kilogram liquid hydrocarbons, that means petrol or diesel. 10 kilogram required to travel 100 kilometers. If this vehicle is run using burning a dry wood for long distance, the mass of dry wood required, we can't say exact mass, but we can decide it is more than 10 kilogram, because the calorific value mean the uh, energy energy production of 1 gram of fuel, it is greater than woods. Hydrocarbons, it is greater than woods. Woods, it is very low value, therefore it is greater than 10 kilogram. A mass greater than 10 kilogram required. A mass greater than 10 kilogram required. We can't definitely give the value. It is, however, it is greater than 10 kilogram. When a fixed mass of compound is heated at constant rate, the time taken for vaporization at its boiling point is greater than the time taken for melting at its melting point. The reason for this, okay, it's an actual scenario, actual case. When a fixed mass of compound, අපි ගත්තොත් 1 kilogram of water, right? 1 kilogram of water heated at constant rate heating, right? Continuously supply heat energy in a constant rate. The time taken for vaporization at boiling point is greater than, if you got 1 kilogram of ice, yeah, ice, continue heating in continuous rate, constant rate heating. Think the time taken for melting, that was 5 minutes. 5 minutes time taken for melting. Full 1 kilogram of ice cube melt within 5 minutes. 5 minutes. But after melting, if we heat up to boiling point and vaporization, for vaporization, this 1 kilogram of water, for vaporization got 8 minutes. මේක තමයි කියලා තියෙන්නේ. ඒකට වැඩි time එකක් ගන්නවලු. The vaporization time. The time taken for vaporization at its boiling point is greater than. That means 100 Celsius. 100 Celsius water to convert into 100 Celsius vapor. Time was 8 as example, right? Example 8 minutes. Zero at melting point, 0 Celsius ice to convert into 0 Celsius water. Only same mass, only 5 minutes. Only 5 minutes. The question asks, what is the reason for this time change? What's the reason for this time change? This actual case. The vaporization at its boiling point is greater than the time taken for melting at its melting point. The reason for that, the heat capacity of the solid is less than the heat capacity of liquid. Okay, the heat capacity or specific heat capacity not involved for the physical state change. No, not involved for the physical state change, right? The latent heat is a case involved for the physical state change. The latent heat of vaporization, vaporization L value is greater than the latent heat of fusion. Fusion mean melting matama. Yeah, that's the answer. Vaporization occur at higher temperature than melting. There is no temperature change in physical state change, no, therefore not temperature involved. Steam is a gas. Steam is a gas, it's not related. The density of liquid is less than the density of solid. The density is not a factor. Answer number 2. Answer number 2. Okay. If you want anything, you can note. Okay, sorry. Okay, 30. Okay, regarding the system in A2 convert to B2, they are the reactant. Two A2 and B2 gases produce AB product. AB product. The chemical reaction is given and balanced chemical equation. And it's produce some energy. Energy means heat. 90 kilocalories of energy. Then it is exothermic or endothermic. What do you think? How about this reaction? Exothermic reaction or endothermic reaction? Yeah, definitely. It's produce some heat. Then it is exothermic reaction. It's exothermic reaction. Answer number 1 correct. Increase the temperature. Increase the rate of reaction. Yeah, that one also correct. Therefore, 2 answers. First one and second one both correct. The amount of heat that we discussed, the temperature effect for rate of chemical reaction that we discussing in next lesson. Don't worry. Okay, first and second both correct. The amount of heat release can be changed by changing the physical state of the reactants. No, the physical state not related to heat change. Increase in the concentration of A2 and B2 does not affect to the rate of chemical reaction. It is affecting the concentration of reactant. The reactant concentration is the main factor affect to the rate of chemical reaction. Answer number 1 or 2. Both correct. Which of following reaction is not an exothermic reaction? Not an exothermic reaction. Petrol combustion, it is exothermic. Adding ammonium chloride into water, definitely endothermic. Ammonium mineral, it is endothermic. Then answer number 2, adding piece of sodium to water, it is exothermic. Exothermic. Mixing potassium hydroxide is a base into hydrochloric acid, HCl mean acid base reaction, exo. Mixing solid sodium hydroxide with water. Sodium hydroxide is a powerful base. Then answer number 2. Answer number 2. Right. A system does, it's a very good question. A system does 4.8 joule. Now this is a system and this is a universe, right? A system does 4.8 joules of work on the surrounding. Yeah, this is a surrounding and this is a system. Make a system, right? The system does 4. Now heat release 4.8 joules work on the surrounding. Work on the surrounding. Then what happened? Heat release or absorb? Heat release 4.8 joules release. And releasing 18.4 joule, again release 18.4 joules into surrounding. The question asks the internal energy change, the delta E value. How to get this? Now you can decide, first you can decide this delta E value, plus value or minus value. Is it plus value or minus value? Yeah, definitely it is minus value because both cases heat loss, energy loss, both cases. Then if you got the loss energy 8 plus 4, 2, 23.2 joules loss, then it is minus 23.2 joules heat loss. It is it's heat loss. Is it clear, Mariam, Dulen? Okay, when 150 joules of work is done on a system by a surrounding. Again, same type question. This is a system and this is a universe, right? 150 joules of work done on the system in energy absorbed, right? On the system by surrounding, 150 absorbed. In order for the systems change the internal energy by delta E. It's a very good question. Delta E equal final energy minus initial energy, right? The delta E value equal 100 joules. The required heat energy changing of the amount, sorry, the required heat energy change of the system must be, okay. Then 150 joules absorb, right? 150 joules absorb. 150 joules absorb වෙලා තියෙනවා. And if it is delta E 100 joules, මොකද වෙන්න ඕනේ? Another 50 joules released to the surrounding, no? If it is really 50 joules released to the surrounding, 50 joules released to the surrounding, internal energy difference plus 100. Clear? Initially 150 joules absorbed to the system. Yeah, if it is released 50 joules into the surrounding, internal energy level 100. Internal energy 100. Internal energy difference delta E 100. Delta E 100. Okay, then the answer is minus 50. Minus 50. Why it is minus? Since it is energy loss. Energy loss. Yeah, it's very simple thing. 150 joules absorbed to the system, and to get the energy change 100 joules, the required heat energy change of the system is must be yeah. I clear that? Okay. To get the internal energy change 100, 50 joules must be lost from the system. Okay, 70. If the heat of reaction for the given reaction is minus 72 kilojoules per mole, heat of reaction given, the amount of heat involved in the production of 1 moles of HCl. Okay, the question asks to production of 1 mole of HCl. HCl is a product. That's the main problem. HCl is product. Its stoichiometric value is ratio 2. Heat of reaction for the given reaction is minus 72. The amount of heat involved in the production of 1 mole of HCl. 1 mole of HCl. Okay, now that's very rational question. Okay, you know, heat of reaction. What's the meaning of heat of reaction? What's the meaning of heat of reaction? What's the meaning of heat of reaction? The amount of heat per 1 mole. The amount of heat per 1 mole of reactants. 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 Now, reactant stoichiometric ratio 1 to 1. Therefore, if you got hydrogen 1 mole, 72 kilojoules per mole, chlorine 1 mole, 72 kilojoules per mole. Are you clear? Up to now, okay? Hi. Hydrogen chlorine 1:1 ratio. Therefore, if you got hydrogen per 1 mole, why it is minus? Is it exothermic or endothermic? Yeah, the reaction is exothermic. Why the heat of, that's why heat of reaction minus. That's why the heat of reaction minus. Hari. Then the reactant and product, sorry, reactant hydrogen and chlorine, the stoichiometric ratio 1:1. Stoichiometric ratio means the front value. Now it is balanced, no? 1:1. Hari. Now if you got this part, this one reactant and product. One reactant and product, what is the stoichiometric ratio? 1 to 2. 1 to 2. 1 to 2. Then to product chlorine per 1 mole minus 72, minus 72 means 72 kilojoules release. That means 72,000 kilojoules. For 1 mole of HCl, for if you got 2 moles, it is 72. Per 1 mole, how many number of joules? 36 kilojoules release. Since it is exothermic reaction, heat release. Answer number 5. Do I need to explain again? Yeah. Yeah, very good question. Thermochemistry maximum advanced question. Okay. Why it is not plus 36? Because reaction in exothermic. That's why the heat of reaction minus. Dulen, clear? Medium? Okay. 18. The heat change taking place during given reaction is minus 760 kilojoule. The heat change taking place during given reaction. Yeah, this reaction, the heat change, it is minus, that one also exothermic. What is the heat change when 0.5 gram of S mean reactant is completely converted into SO3? To completely convert into SO3, the S sulfur molar mass is given 32. Then sulfur molar mass 32 mean number of moles. Yeah, 0.5 grams over 32 GMOL minus 1. What's value? Okay, get this value. Okay, sorry. Okay, what's the value? 0 point 0.015 or 0015? 015. Okay, 0.015 more. 0.015. Okay, 0.015. This is the number of moles per 0.5 kilograms of sulfur. 0. What is the heat change when 0.5 gram of solids completely convert into SO3? Now, 0.5 grams completely convert into SO3. SO3, it's 2 moles, no? 2 moles. Sulfur 0.015 moles completely convert into SO3. The not the heat of reaction, the heat change is given. Okay, let's see. It is 760 divide by 2. Yeah, yeah, this is the way. First, you have to divide the heat change taking place during the given reaction. The heat change is given, it is minus 760. Now it is for 2 moles, no? 2 to 2. Then first you have to calculate per 1 mole. 1 mole per 1 mole. Heat change. Heat change per 1 mole heat change. For 2 moles, it is minus 720. Then divide by 2. Divide by 2. Then you can get per 1 mole, right? Per 1 mole, it is 700 minus 760 divided by 2. 760 divided by 2, what's the value? 380. 380. Minus 380 kilojoule. Now per 1 mole, it is minus 380. Then you can get per this number of moles multiplied by this value. 380 into 0.015. 380 into minus 380 into 0.015, then you can get for 1 mole. For this amount of moles. For 1 moles, this is amount. This amount. Minus 380. Okay, it is minus multiply it is minus 5.7, right? Minus 5.7, approximately minus 5.9, because this is not the exact answer, no? I think, yeah, minus 0.015625. Yeah, good. Yeah, answer මෙතනට මේ දිගම එක දැම්මොත් answer එක හරිම 0.015625 625 moles. Let me check. Yeah, now correct. 5.9 minus 5.9. Good. Answer minus 5.9. Okay, again, same type question. The heat of reaction for the following reactions are plus 128 kilojoules and okay, what do you think? This first chemical reaction, exothermic reaction or endothermic one? Exothermic or endothermic one? Yeah, definitely. The first chemical reaction is endothermic. Why? The heat of reaction plus value. The second reaction, it is minus value. Is exothermic or endothermic? The second reaction, the second step is endothermic. Sorry, exothermic. This one endothermic. This type may reactions we called as multi-step reactions. Multi-step reaction. This is the first step. This is the second step. More than single one step. Based on the above reactions, what is the heat change when 1 mole of it 1 mole of CH3OH is completely converted into carbon dioxide? 1 mole completely convert into carbon dioxide. Okay, how to calculate? Okay, that one also same. Two carbon dioxide moles in products, 2 carbon dioxide moles. Therefore, methanamine 2 calcium oxide, methanol 1 methanol, CH3OH mean methanol, 1 methanol convert into 1 CO, it is 128 kilojoule, right? But it is 2 convert to 2, therefore, මෙයා බෙදන්න වෙනවා දෙකෙන්. Divide by 2. 393.5 divided by, it is minus 393.5 divided by 2. Minus 196.75. Now you can get the difference. It is minus value definitely. Minus value. Yeah, minus value. $68.75. 68.75 minus kilojoule. Minus 68.75. Are you clear? You met? Okay, 17 and 18 bit 18, 19 මේ questions එක චුට්ටක් අමාරුයි. That's only difficult questions. Okay, final question, very easy again. In which of the following scenarios does the energy of the system always increase? The energy of system always increase when the system loses energy and does work on the surrounding. When the system loss energy and system loss energy mean decreasing energy loss, therefore this is not the answer. When the system absorb energy, that's okay, and does work on the surrounding, system doing some work, then heat loss, make a better. When the system absorb energy, that's correct, and work is done on the system by the surrounding, that's one correct. This is answer. When work is done on the system by the surrounding, work is done on the system by the surrounding, that one also correct. None of the above make a. Now we have two answers. What's the most accurate answer? Most correct, accurate, third one. Fourth one also correct, but you have to select most appropriate answer. MCQ part is done. Let's move into structured part. Name two physical quantities. The structured part very simple. Name two physical quantities Q over T, and it is theta. Theta 1 over theta 2 divided by D. Okay, Q over T means thermal conduction rate. Thermal conduction rate or heat conduction rate. Conduction rate. Thermal conduction rate. Theta 2 minus theta 1 divided by D mean temperature gradient. That one also part of thermal conduction rate equation. It is temperature gradient. Temperature gradient. Temperature gradient. Temperature gradient. Temperature gradient. Temperature gradient. Write the equation. Write the equation for the thermal conductivity involving above coefficients. Involving above coefficient. What is the equation? Q over T equal Ka theta 1 minus theta 2 divided by DOL. Okay, what's the name of Q over T? The thermal conduction rate. Thermal conduction rate is a Q over T. K mean thermal conductivity. A mean the cross section area. Theta 1 minus theta 2, the temperature difference. The distance or the length. DOL DOL, right? In an air conditioned computer lab, the inside temperature 20 Celsius and the outside temperature 30 Celsius. Only a wall of 5 meter length and 2 meter height and 20 centimeter thick conducts heat into the room. Find the thermal conduction rate through the wall if the thermal conductivity of the material of which the wall is made is 4 watt per meter per Kelvin. Thermal conductivity unit is watt per meter per Kelvin. It is given, it is 4. And the question asks what is the thermal conduction rate? The conduction rate is asking. Okay. Now Q over T equal Ka theta 2 minus theta 1, that's mean temperature difference divided by D. Okay, Ka. The thermal conductivity is given 4 watt per meter per Kelvin into the cross section area. What is the wall cross section? Cross section area. This is the wall. This is a wall 10 meter length and 5 meter length and 2 meter height. 5 meter and 2 meter, and its thickness only, this is a thickness only 20 centimeter. This thickness only 20 centimeter. Thickness only 20 centimeter. Then what is the cross section area? 5 into 10 it is, 5 into 2 it is 10 square meter into the temperature difference inside 20 Celsius due to air conditioner and outside 30 Celsius, then 30 minus 20, 10 is the temperature difference. Divide by the what's the distance or length heat conduct. It is a thickness. This is the inside or outside. Outside came, this is outside and inside. Outside 30 Celsius, inside 20 Celsius. Then heat passing through the wall 30 Celsius to 20 Celsius. Outside to inside. Then what happened? What's the distance? 20 Celsius. 20 centimeter. Then 20 centimeters means 0.2 meters. You have to convert into meters. Right? Now you can solve this. 4 into 10, 40. 40 into 10, 400. 400 over 0.2. It is 2000 watt. 2000 watt means 2 kilowatt. 2 kilowatt. 2 kilowatt. 2 kilowatt. Okay. To increase the energy efficiency of the laboratory, 1 centimeter wooden layer was connected to the inside of the wall. Calculate the temperature of intersurface. Intersurface means the connecting surface of two walls. Two walls mean wall and wooden layer. The connecting surface. Thermal conductivity of wood is given as 2 watt per meter per Kelvin. Okay, first you have to understand this case, this application. Now think this is a wooden layer. Wooden layer. Sorry, this is a wall. This is a wall. And this is a wooden layer. This is a wooden layer. The wall thickness 20 centimeter. The wooden layer only 1 centimeter. 1 centimeter. Right? This is the inside 20 cells. Inside and make a connector and inside, right? Connected to the inside of the wall. Inside. Then it is 20 Celsius. Wooden layer side 20 Celsius and at the environment outside 30 Celsius. 30 Celsius. Calculate the temperature of intersurface of the wall. Yeah. The question asks what is the temperature of this intersurface theta. Theta intersurface. The question asks what is the value of theta. What's the value of theta? What's the value of theta? Okay. Now, okay, first you have to get two equations. Now Q over T, I'm going to use the thermal conduction rate equation for wall first. First for wall. Wall the thermal conductivity of the wall, Kn, K for 4 into cross section area 10. Temperature difference now. This is outside 30 and theta. Outside 30 and theta. Then what is the temperature difference? Theta minus 30 or 30 minus theta. Can you send this? What's the temperature difference? Outside 30, eh? You can't see this. 30 Celsius. 30 minus theta because theta less than 30. Theta less than 30. 30 minus theta. Okay, ගොඩක් අය මේක වරද්දලා තිබ්බා. 30 minus theta. 30 minus theta. 30 is the maximum value, greater value. Okay, this is my first equation. Divide by length. Divide by length means 0.2 meters. This is my first equation. Okay. Again, I can get another equation. Q over T equal 2 over, now wooden layer K value 2 into same cross section area. Now what is the temperature difference for wooden layer? Theta minus 20 or 20 minus theta. Theta minus 20 or 20 minus theta. Yeah, theta is greater than 20 now. Theta minus 20. Theta minus 20 divided by 0.01 because 1 centimeter is the thickness. 1 centimeter is the thickness. This is my second equation. Right. Now, I told in the steady condition, in steady condition mean the heat flowing rate, the thermal conduction rate for both walls and wooden layer, we have to get as a same value. Same value. Then first equation equal to the second equation. Second equation. 4 into 10 into 30 minus theta divided by 0.2 equal 2 into 10 into theta minus 20 divided by 0.01. Right. Now I have equal two equations. Now 10 to 10 cancel out both same. 4 to 2 cancel, it is only 2 remain. However, okay. Then we can run 30 minus 20 and 20 theta minus 20. 30 minus theta. Okay, 2 and 0.2 we can cancel out, no? May I cancel 2 and 0.2. Then it is 2 divided by 0.2, it is 10, right? Yeah, 10. Now it is 1. Okay. 10 into 30, 300 minus 10 theta equal theta minus 20. Now 1 into theta, 1 into 20 divide by 0.01. Now cross multiplication, 0.01 into 30. What's the value? It's 3, no? Now cross multiplication, this part cross multiply by this one, 3, no? 3 minus 0.01 into 10 theta. Get it? 0.1 theta. Good. 0.1 theta equal theta minus 20. Right? Now 0.1 theta minus, get into opposite side. Then it is 23. Minus 20, get into this side. 23 equal 1.1 theta. Okay, now you can get the theta. 20.9. 20.91 Celsius. Are you clear? The long calculation. Okay, I'll show you full calculation. Yeah, this is my first equation, second equation as simultaneous equation. I solve this, not simultaneous equation. First equation equal to second equation. Then you can isolate the theta. Okay, any doubt? Understood? Twenty point nine one. 20.91 is the temperature. Okay, B. A linear aluminum metal strip in the laboratory is 6 centimeter length. When the air conditioner turned on, the temperature of metal strip dropped from 30 Celsius to 20 Celsius. If the linear expansion coefficient of aluminium is 2.5 to 10 to the power minus 5 per Kelvin, I told it is minus 5 per Kelvin. In exam time, I gave you this value. Minus 5 per Kelvin, not minus 5 per Kelvin. Calculate the reduction of length. That means delta L. Delta L. You know equation delta L equal L1 alpha delta theta. L1 initial length 6 meter. Alpha 2.5 into 10 to the power minus 5 per Kelvin. Temperature difference 10. 2.5 into 10, 25. 25 into 6, 50. 50 into 10 to the power minus 5 meter. That means 0. 6 centimeter. Okay. 6 centimeter. The answer also coming with centimeter. No need to convert into meter. No need to convert into meter. Answer also coming in centimeters. 0.0015. 1505. Okay, 115, sorry. 115. Yeah. Okay, note down. Okay, next one. What is the length of the what is the length of the metal strip at 200 Celsius? 220 Celsius. What is the length of metal strip at 220 Celsius? 220 Celsius mean when it is drop, temperature drop. 30 Celsius 6 centimeter. Then to get L2 mean final length, 20 Celsius, sorry, 30 Celsius 6 centimeter, then L2 equal L1 initial length. It's not an expansion, it's contraction, right? Contraction minus delta L. Delta L. Meya adu karannu. 6 centimeter minus 0.0015 centimeter. Now you can get the answer. Answer 5.9985 centimeter. 9985 centimeter. Right? Very simple. A vessel in above laboratory contains 2 kilograms of water with a several times the water temperature has dropped from 30 Celsius to 20 Celsius. Calculate the amount of heat required to bring the water back to its previous temperature. That means 20 Celsius to 30 Celsius. Then Q equal mc theta, no physical state change. mc theta mean mass 2 kilogram. Specific heat capacity given in standard unit 4200. Temperature difference 10, 20 to 10, 20 to 30. Then 84,000 joules or 84 kilojoule. 84 kilojoule. 84 kilojoule. How much heat must be supplied to rise the temperature from 20 Celsius to 30 Celsius if this water kept in a copper tank? දැන් තියෙන්නේ same water amount in a copper tank. Then Q equal copper container absorb heat, container absorb heat plus water absorb heat. Water absorb heat. Container absorb heat plus water absorb heat. Container absorb heat, the heat capacity is given. Then C theta plus 84,000. ඒකයි හදන්න ඕනේ that you already calculate. 84,000. C mean heat capacity 100 joules per Kelvin into temperature difference 10 plus 84,000. මෙතන Kelvin to Kelvin cancel. In 1,000, 85,000. 85,000 joules or 85 kilojoules. 85 kilojoules. They are very simple parts. If you have any doubt, you can ask. Mariam, I clear? Now, this is the most important part. 50 gram of ice at minus 10 Celsius was added into the water container mentions previous part. Water container water container, right? Container not only for water but after heating into 30 Celsius. 30 Celsius. Calculate the final temperature of water container, right? Not only for water, that you clearly understand. If lost 2 joules of heat to the environment, when mixing, the specific latent heat of ice at melting is given 720. Maybe it's very simple question. First, you have to get the mixed method, right? Mixed method. Then balandone water plus calorimeter. Calorimeter means contain. Release heat. That's a heated one, 30 Celsius, right? Release heat equal to what? Ice absorb heat. Ice absorb heat. Ice absorb heat. Ice minus 10 Celsius. Ice minus 10 Celsius. Now, now water absorb heat. Water absorb heat. Can you say it is 84,000? No. 84,000 for increasing by 10 Celsius, but it is a mixture. It is mixture, not 84,000. Water absorb heat, MC theta. MC theta, again you have to substitute. Calorimeter release, sorry, not absorb, releasing. Now they are releasing, right? Release heat, MC calorimeter, you have to get C theta because heat capacity is given. Equal to ice minus 10 Celsius ice first reach to melting point ml plus melted water melt again reach to the final temperature mc theta. Are you clear? Okay, this is equation mc theta plus c theta equal ml plus mc theta. This is for ice, ml and mc theta. This is for water. This is for calorimeter or contain copper calorimeter. Right. The mass of water 2 kilogram. Specific heat capacity of water 4,200. Temperature difference of water. Can you send me? Water initially 30 Celsius. It's reached to the final temperature. You met. What's the temperature difference of water? What's the temperature difference of water? Yeah, 30 minus theta. Great. 30 minus theta. Plus heat capacity of calorimeter 100 into temperature difference. Calorimeter also same. 30 minus theta. Initial temperature 30 equal mass of ice. Mass of ice 50 grams. 50 50 divided by 1000. L is given 720. Plus 50 over 1000. After melting, same mass, right? Melt to same mass 50 over 1000 into specific heat capacity of water. It is given 4,200. Then melt already. into temperature difference. Make a down below. Met me. What's the temperature difference for ice after melting? After melting mean 0 Celsius, heat to theta Celsius. Then which one is greater? How the value? Theta or 0? ml plus mc theta plus 2 joules. The release heat by calorimeter and water, 2 joules released to the environment. Released to the environment. හරි. මෙතනට තව එකක් ඇඩ් වෙනවා. මේ පැත්ත ආයෙ හදන්න. හරි. ආයෙ බලමු. Okay, this is mass into specific heat capacity of ice, also similar to 4200. Temperature difference 10. It is 10 now. 10 mean minus 10 to 0 Celsius. Yes, we have. ml mean mass into 50 over 1000. Then we got a bigger 10, 50 over 1000 into 720. 720 plus again mc theta. mc theta mean mass 50 over 1000 4200. Its temperature difference is theta minus 0. හරි මෙහෙම theta minus 0. Don't get this complex. Plus 2 joules. 2 joules උත් එනවා මම ඊට පස්සේ දාන්න. It's not too hard, right? මේක අපි solve කරගමු. 30 to 30 cancel. 5 into 42, it is 210. 210 into 10, 21,000. Sorry, 2,100. Plus 20 cancel, it is 36. Plus 30 cancel, 210 theta plus 2 joules. හරි ඔන්න ඔය ටිකේ. Now මෙහෙට එන්නේ 3000 minus 36 minus 2100 minus 2. Okay, now you can get theta terms into this side. 210 theta plus 8400 theta plus 100 theta. Can you get this value? The total value of the left side. Total value of this side 210, 8400 and 100. 8400, 8700 10 theta. Then you can isolate the theta. Then gonna theta equal this value divided by 7,000, 8,710. Yeah, answer 29.03 joules. 29.03 joules. 29.03 joules. That's the exact final answer. Right? That means initially 30 Celsius this container, after adding 50 gram of small ice cube, right? Small ice cube, the container getting 29 Celsius, not joule, Celsius. 29 Celsius approximately. Right? එකකින් වගේ අඩු වෙන. I got Dulen? Yeah. Clearly note down. Temperature drop by 1 Celsius approximately. එකකින් වගේ අඩු වෙන. Okay. An apparatus used for the production of calcium oxide from calcium carbonate is shown below. The lower end of this stream heater is maintained at 900 Celsius, while the upper end it maintained around 200 Celsius. Calcium carbonate is introduced from the top and it's converted into calcium oxide inside the stream heater. The process is repeated by the following, represented by the following reaction. Right. The representation is given. Calculate the mass of calcium oxide produced in a small scale factory where 1 metric ton means 1000 kilogram. Calcium carbonate is converted to calcium oxide within an hour. We don't need time. Make a within, if we added 1 metric ton, 1000 kilogram of calcium carbonate, how much calcium oxide will be produced? Okay, molar mass is given. Calcium carbonate 100.09 grams per mole. Molar mass of calcium oxide 56.08 moles. Okay, now you have to check this balance is equation balance or not. Balance is it balanced? Calcium 1, carbon 1, oxygen 3. The equation already balanced. Therefore 1 mole of the stoichiometric ratio 1 to 1. 1 mole of calcium carbonate produce 1 mole of calcium oxide. Where are you mean? Theta minus. What's the problem? Medan theta minus 0. Yeah, theta minus 0 mean මෙතනදී අපි මෙතනට එද්දී it's already melted, right? Melted mean 0 Celsius water. 0 Celsius water convert to theta Celsius water. Final temperature water. Then what is a higher temperature? Theta is greater than 0. Then theta minus 0 is the temperature difference. The stoichiometric ratio 1 to 1 and make it කියන්නේ 1 mole of calcium carbonate produce 1 mole of calcium oxide. Then if you got their molar masses given 1 mole of 100.09 grams, ඒ කියන්නේ 1 mole එකක් කියන්නේ 100.09 grams. No? If we reacted 100.09 grams, it's produced only 56.08 grams of calcium oxide. ඉතුරු ටික හදන්නේ මේවා. Sorry. The remain is carbon dioxide. The remain is carbon dioxide. මේ දෙන්න add කරොත් the answer 100.09. Right? Then we need 1 kilogram, 1000 kilogram, 1000 kilogram. Then you can get if we react 100.9 gram, only produce 56.08 grams. You want for 1000 kilograms. Then gram to gram cancel. Then you can get the answer. Methane 56,080. 56,080 divided by 100.9. 555.79 kilogram. It is 09, no? Sorry. 09. Then divide karan 09. 560.29. Understood? Vihenga? Okay, final question. If the temperature at which the relevant reaction for calcium oxide production take place is 900 Celsius, what is the amount of heat required to rise the temperature of 1 metric ton, that means 1000, up to 900 Celsius? Again, same type question. Q equal mc theta, make mc equal theta. Q equal mc theta. The specific heat capacity given 1000 kilogram is the problem is 1000 kilogram, the specific heat capacity given in grams. Then you have to convert into grams. This is a grams into 0.9 jg minus 1 Celsius minus 1 into temperature difference 30 Celsius to 90 Celsius. It is 870 Celsius. 870 Celsius. Per Celsius to Celsius cancel. Gram to per gram cancel. මෙන්න මෙතනින් එනවා අපිට answer එක. $870 into 0.9 1 2 3 4 5 6 joules. Right? If you convert this value into kilojoules, 783,000 kilojoules. If you convert to megajoule, 783 megajoule. Any answer correct? Okay, this is the end of last week exam paper. Okay, I'll send the final updated schedule from next month and we start the first part of kinetic chemistry next Wednesday. Then we can continue our Wednesday class from this one, this week. And Friday also you have class on starting from the final week of this month. So it's hard to understand some questions whether they are exo or endo in some special cases. And when breaking down decomposition reactions, can't understand molecules bond separately or right hand side of equation. And when the breaking down decomposition reactions, can't understand how the molecules bond separate on right hand side of equation. Meva, calcium carbonate. You're asking how to produce calcium oxide and carbon dioxide. Yeah, to understand them, we have to more dealing with chemical reactions. Say, product practice එකත් එක්ක තමයි හුරු වෙන්න වෙන්නේ. This is a practical experiment in the calcium carbonate. Calcium carbonate mean limes, right? Limes. In burning, it is produced dry limes. Dry limes mean it's calcium oxide and release carbon dioxide. If we මෙහෙම කරොත් calcium carbonate react with water, then what are the products? Calcium carbonate react with water, then it is calcium hydroxide හැදෙන්නේ. Calcium hydroxide. Calcium hydroxide. Okay, I'll explain in our kinetic chemistry lessons also. We discussed a lot of equations. After kinetic chemistry, I will, in revision classes, I will discuss more questions related to chemical reactions and balanced chemical reaction. And මේ වගේ තියෙනවා ඔයාලා O level වල කරා single displacement, dual displacement, different types of reactions, chemical reactions. හරි අප කරමු. Okay, good. Any other doubt? Okay, then let's meet Wednesday, 7 p.m. with our new lesson, kinetic chemistry. You can collect tute before that. Okay, goodbye. Good.